Hello and welcome to Section 3.5. I am re-recording this lecture because I said a couple of things backwards in the last one, and I want to make sure that I provide the correct information for your lecture notes. Your book has always been right though, so you can always look at that as well. It was just my mistake that I made in my last video. Okay, so in Section 3.5, we're looking at chemical reactions and how to determine which side of the equilibrium arrows is favored whenever you are doing an acid-base reaction. And we're using a qualitative analysis method that is the REO method that we used before in order to make this determination. So in every case, the first thing you need to do is to determine which of the chemicals involved is a base, because it's the bases using the REO analysis method that we compare. So looking at this reaction, we have an acid and a base, and then the acid loses a proton to form the conjugate base, and the base gains a proton to form the conjugate acid. They go together kind of like this. Okay, so the question is then, which of these is most stable? The most stable one, the most stable base here is a little hard to tell when the reaction isn't like truly shown there. So we're going to show an example of some real world chemicals very similar to one in your book and go through the same process. So in this example, we have an amide reacting with a deprotonated thioamide. Thio is the prefix for something that is that has a sulfur replacing an oxygen. And then we will also compare that to a deprotonated amide and a thioamide. All right, so the first question is, which of these is an acid and which of these is a base? So just like before, it looks like this chemical is an acid because it has lost a proton in the products, which makes this the conjugate base. And then in the sulfur one, that looks like the base because in the products, this looks like it has gained a proton. Remember, acids lose a proton and bases gain a proton. All right, so they kind of go together like this. Great. So now the question is, which of the two bases, the base and conjugate base, is the most stable? All right. So here we are. We have these drawn. And we can really just use our REO rules now to determine which is most stable. So atom differences first. Remember, in the atom differences, we're looking at differences in the same row. So the same row, we're talking carbon, nitrogen, oxygen, fluorine, we're looking at differences of electronegativity, right? But in the same column is more important because you're looking at differences in molecular size. So that means if you have an oxygen, it will not hold a negative charge as well as a sulfur as it goes down the column. So this is something that we need to keep in mind. However, in this case, the negative charge that we have is both on a nitrogen. So I don't think in this case, A is the main thing that we use. What about R? Do we use R? Well, you can make a resonance structure here to give you this molecule. There we are. Nope, forgot the negative charge. And you can do the same thing on the other side here to give a very similar structure. But I think you'll find that these have a very key difference. Which is that now the negative charge is either on an oxygen or on a sulfur. And we just talked about how an oxygen cannot hold a negative charge as well as a sulfur. So even though we're looking at resonance here, we have to go back and apply one of the atom principles to this selection process. So it looks like by that logic, this is the strongest or the most stable conjugate base. So if that's the most stable conjugate base, its acid is the strongest acid, right? So what is that one? That one looks like it is the base. So its conjugate acid is the strongest acid. So we'll write in Ca, which means the reactants are favored because the same side of the reaction that the most stable conjugate base is the same side of the reaction that is favored. All right, that should clear it up. This is section 3.5.